So now that we've played with some exponential equations a little bit, let's see if we can solve a couple more. Let's say we had 2 to the x power is 16. So thinking about your powers of 2, we know 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16. So hey, x must be 4, right? And we know that just because it's a power of 2. So what about 3 to the x, or 3 to a power is 1/9? Now, if you remember anything about exponents, remember to create a fraction using an exponent, your exponent must be negative. So I know my answer is going to be a negative number because there's a fraction. So then all we have to do is think really about 3 to what power is 9? And hopefully we all know that's 2 because 3 squared is 9. Just to account for the fraction, we'll make it negative 2. Okay, so 3 to the negative 2 means I want to square the 3, but I have to make a fraction out of it. So it's 1 over 3 squared, or 1/9. Okay, so just a quick check. So what about 4 to the x equals 10? All right, do we all know our powers of 4? I know my powers of 4, like 4, 16, 64, 256, I think. I mean, right? But I don't know a power of 4 that equals 10. So not every exponent works out to be a nice whole number that we're aware of or that we know, which is why we need logarithms. I like to think of the logarithm or a log as the what power of rule. Okay, so if you just consider a log a what power of, then whatever you have learned about logs in the past will hopefully become a little clearer. Okay, so a logarithm is the inverse of an exponential function. It solves for an exponent. Anytime we have an exponent of x that we don't know, like unlike the first two, then we're probably going to use a log to help us solve that because a log finds a power. It is a what power of rule. Okay, so just first off, some forms. In exponential form, we would say 8 squared is 64. In log form, I would say log, and then what power of 8 is 64? So what power of 8, here's my what power of, 8 is 64. And I know that answer is 2. Okay, so log, what power of 8 is 64? Well, it's 2. So that's my answer. Okay, so that's our format. You'll see the 8 is the base of the exponent. The 8 is also considered the base of the log. The 64, which is the answer to this exponential form, is actually what we're finding the log of. And then 2, which was our original exponent, becomes the answer to the log. So I'll break things down here in just a sec. I just wanted you to see that format. Okay, so let's try 6 to the negative 2 equals 136. So I'm going to say log. What power of 6 is 136? It's negative 2. Okay, so again, 6 the base. 136 is what our answer was. Negative 2 is what the exponent was. Let's see if we can go backwards. So this is saying log, or what power of 2 is 32? It's 5. So that must mean that 2 to the 5th is 32. Okay, just a little shortcut on this if you need it. If we start with the base, we can circle around. That is the exponent, and that is the solution. So 2 to the 5th equals 32. I can do the same thing here. Log base 2 of 32 equals 5. So it's almost like a circular little function if you need that. Now let's talk some terminology. When we have something like log, I'm going to put a B and an A. B is called the base. A is called the argument. I always forget if there's an E here. That looks funny. I'm going to take it out. So I'm going to assume there's no E in argument. Argument. Although that looks funny too. Whatever. Okay. So log base B of A. So base B argument A. So 8 is our base. 64 is our argument. Okay. 6 is our base. 136 is our argument. And we will say log base B of A. Log base 8 of 64. All right. Okay. A couple logs that we will be using a lot. First off, log base 10 of whatever. Log base 10 is called the common log. Okay, anytime you have a base 10, that's called the common log. And it's so common that we don't even have to write the base out. So if you see a log without a base, you will assume it is base 10. Okay, So log base 10 can also be written as just log, and that would just be log of whatever. Log base e, if you remember, e is a number, so log base e, that is called our natural log. Ooh, that looks, I'm going to write that, natural log. And that's because the number e is called the natural number. Okay, so natural log, log base e, now that's going to be used so much, it also has its own terminology. And that is where we get ln from. I think it's actually like French, which is why it's in what seems to us like the reverse order. It's like logarithmic natural, which I never took French, so I'm sure that's not how you say it, but that's why it's ln. Okay, so that is the natural log. That means that we are assuming it's a base of e. All right, now your calculator has buttons for both of these on the main screen. So I'm going to pull up my calculator, clear out what I had. First off, you see your log button here. That again assumes log base 10. So if I type in log of 4, this is saying what power of 10 is 4, and it's the 0.6 power. Okay, so that tells me that 10 to that power, just to check, 10 to the exponent of that thing must be 4. Okay, so this is the exponent that would go on 10 to get an answer of 4. And then again, we also have an ln button just below the log, and that builds in the base of e. So if we say ln of 5, this would be saying what power of e, because remember e is your base, what power of e is 5? Well, it's the 1.6 power. Okay, and again, I could check. If I do e, so I'm doing my second ln, to that power, I should get 5 as an answer. Pretty close, right? Because it had to round it off. So remember, the answer to a log, and these are both logs, is the exponent that would go on the base. Okay, so some properties, if we keep that in mind. So first off, we have log base a of 1. So what power of a equals 1? Well, if you remember your exponent rules, anytime you have an exponent of 0, doesn't that equal 1? Okay, so oh wow, I'm not writing well today, everybody. So that tells me any log of 1, no matter what the base is, should be 0. So I'm going to say because a to the 0 equals 1. Okay, so again, we're finding the missing exponent. All right, how about number 2? What power of a equals a? So what exponent can I put on a to get an answer of a? And that would be 1. Why? Because a to the first equals a. Remember, these are our missing exponents. A to the first equals a. Okay, how about number 3? We're getting a little more complicated. What power of a can I use to get a to the x? So I'm going to skip ahead because a to the something equals a to the x. Well, how do I make the left side look like the right side? I use an x. Okay, so here's a little shortcut. If your base and your argument are the same value, your answer will be the exponent. Okay, because a to that power equals a to the x. So base and argument the same, your answer is your exponent. So let's think about that in terms of a natural log. If I have the natural log of e to a power, remember a natural log has a base of e. Even if you need to write it in there, go for it. Natural log of e, okay, so I've got my e and my e. E to what power equals e cubed? That would just be 3. So any natural log of e is just the exponent. Or what if I did this? Log of 10 to the 5th. Remember, a log with no base is automatically a 10. So base and argument are both 10. My answer is my exponent of 5. Okay, so just a couple nice examples there. If you recognize those, you're going to save yourself some trouble in the long run. So if the base and the argument are the same, your value is the exponent because a log is asking what's the exponent. We got it. It's right there. Next one's rearranged a little bit. So again, I still have a base or 2 bases the same, really. This is just going to be a value of x. Okay, if you think about this in log form, it's log base a of x equals my exponent. So it's kind of a circular definition there, but if you have the bases the same, your answer is whatever the argument is. Okay? And then the last one, if two logs are equal to each other and they have the same base, can we just assume that the arguments are the same? Yes, we can. So if two logs are the same, arguments are the same, then, or if two logs are the same, bases are the same, then arguments are the same. Okay? Okay, I'm going to stop this video here. Actually, no, I'm lying. I'm going to keep going, so we can just make one long one. Now, change of base formula is kind of outdated because most of your calculators at this point have this built in. The problem was it used to be like we couldn't find anything but log base 10 and log base e on our calculator, but now we can. So I just want to go ahead for people who have an older calculator that won't change. Let's say we have log base b of a, and we want to be able to calculate this, like this log base 2 of 5. So we're going to have to change it to a base that we can calculate on, especially an older calculator. I want you to change the base to either 10 or e. Okay, so I'm going to go ahead and just change it to 10. So I'll just leave my base out. It becomes log of the original argument over log of the original base. Okay, so the base heads to the bottom, the argument heads to the top. So if we have something like log base 2 of 5, I'm going to again write this both as log base 10s. So using that common log, the original argument heads to the top, the original base heads to the bottom. So if we want to calculate this, I'm going to scoot this over a little bit. I can now type in log of 5 divided by log of 2. Okay, so this is telling me what power of 2 equals 5. This is the exponent that I could put on 2 to get a value of 5. Now, in your calculator, I always have trouble finding it. I know it's in the math menu. Nope. Maybe it's under math here. Oh, there it is. Okay, so I'm in the math menu. If you scroll up from the bottom, you see log base. I think there's an easier place to find it too. We may have to talk about it in class. So I'm going to go ahead and choose log base, and it'll give me the option to change the base. So if you have one of the newer calculators that will do that, by all means, take advantage of that. Okay, so I can type in log base 2 of 5 and hopefully get the same value, and look, we do. Okay, so you can either write the ratio, original argument on top, original base on bottom, or you can use your calculator option to change that for you.